First of all, good morning, everybody. Good afternoon, depending on the part of the world you are connecting from. So let's start. Today we are going to count with two speakers. Matt, who is the author of the Year's Easy Approach for Requirement Syntax, and Jose Fuentes, who is the Chief Operating Officer of Reuse Company. The contents from today's webinars will be the brief introduction of the Reuse Company, and we are going to do a brief introduction of the presenters. Then MAP will take on and do a presentation of the easy approach to requirement syntax years. Then Jose will present how this approach has been mapped into a knowledge library, so all the users of our tools can download it and use it. And finally, a presentation of use cases and a live demo. And at the end, we will have let's hope we have time to have a QA session. Okay, brief introduction so we don't waste too much time. The Reuse Company was established in 1999 as a spin-off of a Spanish university. Our team is it's made up by a combination of system and software engineers. We are also very involved in artificial intelligence and NPL, natural language processing. Our headquarters are in Madrid, and we have offices in Stockholm and a delegation in Tokyo. And our main objective is to provide a knowledge-centric approach to improve all the activities in system engineering in all our customers. As I mentioned before, we are very happy to have a map as our guest speaker in this webinar. He, as you all know, MAP is a very well-known consultant with over 20 years of experience in requirements engineering. He is the lead author of the EARS notation, which has over 20,000 reads on the ResearchGate. He also has experience in requirement engineering and system engineering in a large number of areas such as aerospace, automotive, defense, industrial plant design, rail, and software systems. He provides training, coaching, and consulting in requirements engineering and, of course, EARS. Jose, our next presenter, I'm sure most of you or some of you already know him from previous webinars or from INCOC. He is the Reuse Company Chief Operating Officer, highly skilled in our tools, and he is INCOC's CSCP certified, an active contributor to the INCOC Guide for Writing Requirements. Okay, having said this, and without any more delay, I will give way to MAP to start his presentation, Introduction to EARS. Please, MAP, go ahead. Thank you.
Okay, thank you. So what I'm going to talk about, the title of the whole webinar is a practical approach, but I suppose more specifically, what I'm going to talk about is what is EARS, briefly describe EARS and the EARS pattern. I assume most people know a little bit about EARS, and in any case, I couldn't do EARS in great detail in the time that I have. I have about 25 minutes in this session. So what is EARS and why do people like it, I suppose, would be my summary of what I'm going to present. So very briefly, the development of EARS, and then describing the EARS patterns. And then I'm going to spend probably most of the time stepping through a sort of draft requirement and showing how applying the EARS approach improves the requirement and what it gives you, why EARS is better than a pure natural language requirement. Then, as it were, some more sort of some more specific benefits of EARS, and then some of the users of EARS, because there's quite a lot of people out there who use it. So the initial development of EARS, how did EARS come to be? Well, if it's going to allow me to advance the slides, goodness me, technology. So EARS was developed whilst I was at Rolls-Royce. That's the aero engines, not the cars. And it was when myself and some colleagues were looking at the EASA CSE, Certification Specification for Engines regulation, and that defines the regulations against which an aero engine has to be certified to fly in European airspace, or at least an aero engine control system. So like many regulations, CSC is it's, you might say, a rich mixture of requirements and goals and information and supporting text and so on. Another way of looking at that is that it's not written well as a requirements document. So it's got a lot of statements that are unclear, vague, ambiguous. It's got some implied requirements. It's got non-exhaustive lists. All the good things that you normally often see in textual documents, against which you might have to write a specification. So we had a cross-discipline team of engineers who looked at that together to interpret it and rewrite the regulations or interpret them into testable, precise, unambiguous requirements. That was myself as a requirements specialist, general systems engineers, safety specialist, crucially the airworthiness engineer from Rolls-Royce, who's the person who signs off to say that they believe our specification meets the airworthiness regulation. And where necessary, we drew in other subject matter experts. So we started with a loose set of rules of essentially my knowledge that I gained over the years previous to that as a requirements specialist in what makes a good requirement. I started with a loose set of rules, and then as we went along, we looked at the requirements that were coming up or the statements in CSE, started rewriting them into clearer requirements. And as we went along, we refined that, and we started to notice that the requirements were falling into a small number of patterns. They looked fairly similar in their shape, and we started to think maybe this was this sort of approach could be applied more widely to other sets of requirements. At least one of my colleagues, Phil Wilkinson, who's a co-author of most of the year's papers, he suggested we ought to write a paper. At the time, I actually thought that there wasn't all that much new in EARS. It wasn't really much of an increment on what had gone before. I thought it was perhaps too simple to really be worth publishing. It turns out that simplicity is exactly its strength. I mean, at the IEEE RE19 conference last year, the first EARS paper from 2009 was awarded the most influential paper. Each conference, they look back 10 years and see which papers had the most impact on the discipline in those 10 years. So it seems that simplicity is exactly what people like. And it's extremely unusual for a practitioner paper, an industry paper, to win that award. So that says something. Anyway, so being practitioners, we actually just did some work that needed to be done. And then only afterwards did we decide perhaps it was writing a paper. But of course, if you've ever written a paper, you need to have a hypothesis and you need to do a literature survey to justify what's the motivation for your paper and that type of stuff. So we had to reverse engineer that because we hadn't actually approached it with the intention of writing a paper. But nonetheless, we could reasonably suggest a motivation for EARS, or perhaps more relevant now, why would someone want to use EARS now? So, well, I would argue that people like natural language. Most people write the majority of their requirements in natural language, in free text, typically English, of course, but any language. And people want it easy. People don't want to learn a specialist tool or need to know some fancy notation where there's, boxes and arrows, and the different arrowheads mean different things, and different shaped boxes mean different things, and there's all sorts of cardinalities and things. The majority of people, if you try teaching them that type of thing, they get a headache and they spend most of their effort, most of their cognitive energy trying to understand the notation, not the content. EARS is because it is essentially still natural language, it's easy for people to digest and to understand. But people want something that gently constrains natural language. You don't always think about it, but language has rules, and of course in spoken English or spoken language and written language, those rules can be applied relatively loosely. I mean, for the purposes of humor and comedy and so on, you can use language in slightly varying ways. But of course, to make a precise testable requirement, you want to use language a little bit more carefully. So I always say that EARS gently constrains natural language. There are obviously rules anyway, but of language, but EARS effectively imposes some more rules or guides that constrains language a little more than you would otherwise, and that constraint is sort of measured. It's just, by measured, I don't mean you actually measure it. I mean it's a small amount of constraint, but it gives you a good payback. And as I said, you don't need a new notation. You don't have to buy a software tool. You don't have to go on a great long training course to understand ears. And indeed, to write ears. And to understand ears requirements, you don't need to know what ears is. You don't even need to know what a requirement is. You just need to be able to read natural language. So ears is easy approach to requirement syntax. So ears is often described as a template. That's partly my fault, I suppose, because I called it a template in the original papers. I'm not entirely comfortable with calling it a template, because when some people hear the term template, they kind of think of a form that you have to fill things in, or a checkbox, or a kind of a script that most people might go through to mechanically come to some result. It's not really a template in that sense. It's a sort of framework into which you slot bits of English in order to come up with a good requirement. So if you don't include the negative aspects of a template, it is a template. It's a slot into which to put words to get better requirements. So the ears template is made of simple clauses, and those clauses are always in the same order. There's a set of rules that govern the order of those clauses, and cardinality, how many of each clause you have, what's mandatory, what's optional, and so on. A lot of this detail is in the papers. All of my papers are available on ResearchGate, and that's referenced several times today. So when you apply the ears template, the resultant requirements fall out into one of a small number of patterns, 6 basically. So at the core, ears is proposing that all textual requirements will be in one of 6 different patterns. So they all look very similar in terms of their structure. So the most generic structure or overview of what an ears requirement looks like is this. So you have preconditions, then trigger, then system name, then system response. So that applies to any ears requirement, and which parts you populate in any given requirement, depending on the conditions that initiate that requirement. Depending on which parts of that are active, you would end up with a different ears pattern. So just a little bit on what all those clauses mean. So precondition, that defines conditions that must be true for a requirement to become active. So that's states of external systems or entities in the domain of the system. So things that happen around the system that you might need to detect that are true for a time. So they're a state that entity or system is in over a period. Once that state is true, you might want to respond in some way. A trigger is a discrete event that a system has to respond to. So a very simple example of that would be a button press. So if a customer presses a button on some system, then you might want the system to respond in some way. The system name, a rule of ears is that the system name should be explicit. You shouldn't just call it the system shall in a requirement. You should explicitly name the system so that it's very clear which target system is responsible for carrying out that requirement. And the system response is something that system itself can do in response to the conditions being met. So when that requirement is initiated, that's what the system has to do. And that order of clauses is central to the power of ears. So I'm very quickly going to go through the different ears patterns. If you want more details on this, as I say, it's in all the papers. So the first and simplest type of requirement in ears is ubiquitous. These are requirements that specify behavior that the system must do continuously, so things the system must always do. There's no precondition or trigger, there's no ears keyword, it's just the system name shall system response. So for example, the mobile phone shall have a mass of less than XX grams. So things like that are high-level system constraints or properties of the overall system tend to be ubiquitous. Complying with regulations tend to be ubiquitous. State-driven requirements, they define things the system must do whilst some condition of an external system is while it's in a defined state. So for example, say the generic form, while preconditions, when system name, the system shall, system response. So while there is no card in the ATM, the cash point machine, the ATM shall display, please insert card to begin. So obviously an ATM cash point, not having a card in is a condition that exists for potentially quite a long time. While that condition is true, you want it to display a message so that people know what to do to begin using the machine. The next part is event-driven. So these requirements are initiated when a particular discrete event is detected at the boundary of the system. So when that event is detected, you want the system to respond in some way. So when trigger, system name shall system response. So for example, when the user selects mute, the laptop shall suppress all audio output. And then those very simple, as it were, vanilla building block requirements of preconditions and events, states and events, they can be combined into what are called complex requirements. So where you have preconditions and triggers. So while precondition, when trigger, the system name shall system response, that's the general form of a complex requirement in EARS. So while the aircraft is on ground, when the flight crew select reverse thrust, the engine control system shall enable reverse thrust. Interestingly, I'll go on to unpack that requirement in a few slides' time. So, and then the next type is unwanted behavior. So this is a construct used to describe how your system should respond to unwanted or unexpected events. So anything that any interacting system or user does that is undesired, unwanted, or unexpected. Things that you'd rather don't happen, you know they will happen at some point, but you know then they're not on the sunny day happy scenario. If any of those bad things happen, how would you like your system to respond? So if trigger, then the system name shall system response. So for example, if an invalid credit card number is entered, then the website shall display, please re-enter credit card details. And then finally, optional feature is a very simple mechanism to handle product and system variation. It's only one way of doing it, and it's a very simple way of doing it. So if your system or product that you're developing is part of a product line or has many product variants, then this probably isn't the best way of doing that. But if you've got a few simple product variants, it's a very, very simple, lightweight way of specifying things that the system may have to do for certain types of that system or for certain versions of the product. So where a feature is included, the system name shall system response. So where the car has a sunroof, the car shall have a sunroof control panel on the driver door. So clearly that feature, that system response is only required in a system that has that feature in the first place. So that was a very quick run through what EARS is, but as I say, more details. But I think for the purposes of this, as I said earlier, I wanted to step through what you might call raw requirement and textual requirement and how it might be improved incrementally to lead to an EARS requirement and the advantages of that. So you could imagine in the early stages of developing an aircraft, someone will draft a requirement to say that the system must be capable of reverse thrust. So when an aircraft lands, the reverse thrusters come on to slow the aircraft down. So you must be capable of having reverse thrust. As a draft requirement to say this is something we need, that's perfectly reasonable, of course, but as a testable, precise and ambiguous requirement, it's not perfect. So how might someone improve that requirement? Well, you might say, the system must include a thrust reverser. So then they're being more clear about what the feature is. Perhaps better, certainly not a great requirement as written. Maybe someone might say the system will deploy the thrust reverser. That's the kind of thing I often see in requirements, because as written, it doesn't say anything about how and when, in what circumstances it should be deployed. So you might append it and say the system will deploy thrust reverser when the aircraft lands. And then you might think, well, actually, what makes that happen? It doesn't automatically happen. So if commanded, so you might say the system shall deploy thrust reverser when aircraft lands if commanded. Now that's, I would argue, got most of the elements of a good requirement, but not in a very good order. In my opinion, it's a little harder to understand because of the structure that's been used. I mean, probably there isn't a formal structure, it's just evolved. So I'm going to unpack that and explain why the EARS construct is better than that. So what I would do with a draft requirement like that is I would look for sort of keywords and phrases that will feed the various elements of an EARS requirement. So to me, the thing that happens first, that then should be the first part of an EARS requirement, is while the aircraft is on ground. So notice in the draft it says when aircraft lands. In EARS, it would be while aircraft is on the ground, because while it's on the ground is a state that the aircraft is in that would be detectable by the system. It's something that persists, so it's a state rather than an event. But while the aircraft is on ground, when the flight crew select reverse thrust, the engine control system shall, so notice being very explicit about the name of the system, the engine control system shall enable deployment of the reverse thrust. So that's got most of the elements have been taken from the original requirement, but they're in the order that's mandated by the EARS notation, and I think it's a more clear and precise requirement. So I'm now going to explain some of the advantages of that. So the clauses of the EARS requirement are in temporal order, so they're in the order, to me, the very logical order in which things actually happen. Now, this is interesting because that wasn't a conscious thing that I or we, when doing the work that led to EARS, we didn't consciously think that. It's just seemed intuitively to make sense. So if you think about an aircraft landing and then reverse thrust being deployed, what happens in order for that to occur? Well, firstly, the aircraft must already be on the ground, otherwise it's not possible to deploy reverse thrust. So the first thing that has to occur in temporal logical order terms is that the aircraft is on ground. So that goes at the start of the requirement. But that on its own won't initiate reverse thrust. That has to be true, and also the reverse thrust has to be commanded by the flight crew. So that's the next thing that happens, and that is a triggered by a discrete event. So that is an event, and that is placed next. In those circumstances, when that trigger comes, then this named system, the engine control system, shall, well, what do you want it to do? Enable deployment of reverse thrust. So it's in the temporal order. The precondition is the thing that must happen first. The trigger is the thing that initiates the system to respond in that way, but only when the precondition was already true. The system name must be explicit, and the system response is something that named system can achieve. A helpful byproduct of the EARS structure is it makes people much more likely to write in active voice. So the flight crew select the reverse thrust. So who does it and by what means, if you like. So that another aspect of EARS is that these clauses, the precondition trigger, tend to help people think about system decomposition. If you have to be able to detect that the aircraft is on ground, that state, then you have to have some means of knowing that the aircraft is on ground. You have to have that information available at the system boundary somehow. And similarly, if you have to be able to detect that the flight crew have selected reverse thrust, how are you going to do that? There must be some way that they can make that selection and your system can detect it. So it identifies the states and events, as I suppose I just said explicitly, which is quite useful for understanding your system and how it interacts with systems around it. Crucially as well, though, the conditions must be necessary and sufficient to result in the system behavior. So they must be necessary. That means you don't put in preconditions triggers that are unnecessary. You don't put in anything that is not relevant to that requirement. So they must be necessary, but they also must be sufficient, meaning you need all of the preconditions of trigger that are included in this requirement. All of them are they are sufficient together. There's not been specified in the requirement in order to lead to that system response. Often draft requirements may lead to several EARS requirements because there might be slightly different circumstances, slightly different preconditions that lead to different system responses that might appear to be quite similar, but when you unpack it and start looking at the states and trigger involved, actually you need to split it into more than one requirement. So those conditions that are necessary to initiate the requirement, the preconditions and triggers, they must be detectable by the named system. But that structure helps you to ensure that the requirements are balanced, by which I mean that if a particular named system, the black box that you're writing requirements for, if that has to respond in some way, then that system at that system level, that system boundary, it must be able to detect the things that are necessary in order to initiate that behavior. So the input process output must be balanced at the same system level. And one problem people often get in writing requirements, if they haven't applied enough rigor and thinking, is that requirements are written at inappropriate levels. You might get a system level document that has component level requirements in it, or super system requirements that should be in a higher level document. EARS tends to help by the fact that the system name is explicit, and then that the preconditions and triggers must be detectable by that system, and the system response must be achievable by that system. They tend to make sure that all the elements of a requirement are at the right level. So the benefits of EARS, in addition to those that I've mentioned as I've gone along, it reduces or even eliminates common errors typically found in natural language requirements. In the first and second EARS paper, there were some EARS and big EARS. We did statistics on sets of requirements, and we proposed that, or identified that there were 8 very common problems with natural language requirements. And in the sample that we studied for those papers, from memory, I think we eliminated 4 of those problems completely and massively reduced the other 4. I'm not saying in that it can eliminate all problems in textual requirements. I'm saying some of the types of problems can be eliminated and others are reduced massively. So EARS improves natural language requirements. It does that without the need for a specialist notation or tool. As I said, little training is needed. So I typically train EARS in a half-day or full-day training. The actual training element, if you like, is half a day. I usually do a full day because the afternoon is then practicing writing EARS for your own domain, so that you get an embedded learning of how to apply it yourself. Other organizations I know train EARS sometimes in as little as an hour. I have trained people in EARS in an hour if they are already well schooled in systems engineering and requirements engineering and understand all that. You can train it in an hour, and people can actually be better at writing requirements quite quickly. A word of caution, though, to do EARS well, you do need to have practiced and got some experience and ideally some training and support. But compared to almost all other notations and techniques and approaches, there's a very low overhead to get started. The resultant requirements in EARS are simple and easy to understand because they're essentially in natural language, so anyone can read them. Many people have commented that EARS is especially useful for people whose first language is not English, but who must write in English. A colleague, a friend from the requirements circuit, who's a big user of EARS and has written papers on EARS, Sarah Gregory at Intel. Intel, typically, they are in something like 60 territories and they have many first languages. Sarah was on a project where I think she said there was something like 13 different first languages on the people involved in this project, and they all have to communicate in English, and they all found that EARS made that much easier for them to communicate consistently. I actually personally think that people whose first language is not English tend to write better requirements than people who are natural English speakers in many cases. I think there's a couple of reasons why people whose first language is not English, why they write better requirements, and also why they like EARS. I think both those things are true for a couple of reasons. One is English people generally don't learn grammar at school, whereas many other countries and many other languages, you learn grammar at school. And of course, the construct of EARS and any well-written requirement is about using grammar well. And the other thing is, I think if you have a relatively small vocabulary, you use a smaller set of words in a very controlled way. So many people who speak a second language with a relatively small vocabulary may be quite precise in how they use that language, that vocabulary, and they can make themselves well understood by using quite a small set of words in a controlled and consistent way. And that's what EARS gives you. It adds to that by using these keywords in a controlled way. So yeah, I often think that non-English speakers or people whose first language is not English can often write very good requirements in English. EARS works very well alongside models because it identifies states and events. So when generating scenarios of various types, so activity diagrams or sequence diagrams, you can use that to generate EARS requirements. Or if you have a set of EARS requirements, you can use that to generate models. And also for state charts and various other work very well alongside models. That's one of the reasons as well why EARS is a very good bridge between informal and formal. So you might say for any system development, you start very informally with a vague need that might ultimately lead to the identification of a system that might be needed. It starts very vague and informal and gradually gets more formal as you get through the system development life cycle. But also stakeholders vary in how much formality they understand or are willing to engage in. And EARS acts as a very good bridge in that sense. You can start writing EARS requirements very early, and it will identify possible states, actors, events, actions, and so on, which will be useful information to understand your system better, perhaps to populate models and so on. So you're starting to add formality relatively easily in the early stages, and it can help stakeholders, those involved in a system, it can help them to start to understand more abstract concepts and more formal models and so on. And all that stuff tends to help expose a lack of understanding. So I think some pure natural language requirements and some other requirements notations will kind of allow people to write slightly vague, ambiguous requirements. The amount of precision that is necessary to write an EARS requirement uncovers understanding. It exposes it. You can't really write a vague requirement in EARS, so it means you must understand the states that exist to which your system must respond. What are the triggers that occur? What events occur that the system has to respond to? Which actors initiate these events? So it uncovers that. And in fact, a good illustration of that is an engineer, senior engineer from a very well-known engineering company. I can't mention them because he wasn't allowed to be quoted. The company doesn't like to ever be quoted to endorse tools or processes. But this guy said that if you can't write it in EARS, you don't understand it. If you can't write a requirement in EARS, it means you don't understand the requirement well enough. So the obvious other side of that is if you do understand it well, you can write it in EARS, and then it becomes clearer. Easier for everyone to understand because it's a simpler, clearer requirement. So it tends to force a better understanding of the system that you're defining requirements for. So you don't have to believe me. These are all companies who use EARS. I've taught at many of those companies, trained. Not all of them. Some of them have picked up EARS from conferences and delivered it themselves. Some of those are universities where I've presented. Yeah. So, and to finish, a proverb. There's an Italian proverb that says, "Making wine is simple but not easy." So, making wine is you basically get some grapes and you squash them and then wait a while and you've got wine. Don't know if there's any more to it than that, but it is essentially very simple. But that doesn't mean it's easy because people try it, and to make good wine takes skill and experience. In some ways, EARS is a little bit like that as well, or writing requirements. The thing about EARS, and I've made this problem for myself in a way by the E of EARS being easy, the first word being easy, it kind of implies that the whole process is easy. I would argue it's easier than many other processes to write requirements. I'd certainly say that's true. But to write very good, clear requirements, so a well-written EARS requirement is easy for anyone to understand, but that doesn't necessarily mean it's been easy to write. Certainly, you need to understand the system that you're going to writing requirements for, and the domain and context. You need to understand all that well. And you probably need a bit of practice, ideally some training and coaching, in order to understand the subtlety and full power of these, to then be able to write the clear, simple requirements. So another analogy there for something that's simple but not easy is something like a very simple line drawing. If I could have got an example, I do sometimes use examples of things like I don't know, Matisse or Picasso drawing I don't know, a face or a vase or a flower with just a few simple lines. And some of those drawings are amazing, and you think that's really simple and perfect. And some people might go, well, anyone could do that, or oh, it only took him 5 seconds to draw. Well, it's simple, but it's not easy, and that can be also true of ears. And just one other thing on that. So the other disadvantage, or a thing about ears, is that people can think, oh, I understand that, it intuitively makes sense, I'm going to write ears compliant requirements, and then they put the word while at the start of a requirement, and then a when, and then a system shall, and they think that means they've written a good requirement. So superficially putting the keywords in, you're going to get some advantage, but that doesn't mean you've necessarily written a clear and correct requirement. So it does take a little more than that. Okay, I haven't really been watching the time, but that's what I'm going to say for now. Thank you.
Okay, thank you, Matt. Thank you for your great presentation. We do appreciate it. And now I will give it to Jose to start his presentation, where he will show you how EAR has been implemented in a knowledge library in our system engineering suite. Please, Jose, go ahead.
Yeah, thank you, guys. Can you see my screen?
Yes, we do.
So thank you, Frank, and especially thank you, Mav, for this wonderful introduction to the EAR's approach. Now, even if, of course, what Mav was mentioning is that EAR's is intended to be a kind of tool-free approach, what we have done is we have implemented this approach into our set of tools aiming to write always high-quality requirements. As probably most of you already know, we like to use the concept of knowledge library or ontology in the smart analysis of requirements. So what we have done is this is normally the shape of our ontologies, made up of 5 different layers, starting with the control vocabulary. It was, as Mav mentioned, very important to name things consistently across the different documents and models in the system. Then the second layer is where those elements in the previous list of vocabulary are linked together or grouped together. Then, of course, it comes in our approach, it comes the patterns, and this is especially where EARS comes into play in the idea of the definition of this sequential number of elements. And then what you find to the left of this screen is just more to the machine, to the computer, to understand what the human is writing in a requirement, so that the inference or reasoning part of the tool can elaborate and provide tips and help people write better requirements. So what we have implemented in these 5 layers, in this case, the EARS library that we have implemented has almost nothing in the vocabulary layer, or let's say, as some of you already know, we have a lot of content in this vocabulary, but this content is not domain specific. So this is meaning that if you could be dealing with aircraft or cars or railway industry, then you will have to populate information or the content of the dictionary for these specific domains. And of course, this is why we have our tool Knowledge Manager to populate these dictionaries. Same kind of for the second layer, the second layer of grouping things together. Is mostly empty. Please take care when you populate the dictionary to populate the elements in the proper clusters or semantic classification of these concepts. So if you provide the name of your systems, then please populate the cluster called system. If you are naming actors, please populate the cluster actors or properties or states or whatever. So do not just populate a list of domain-specific keywords, just put it under the proper cluster. Then, of course, the strong point of this library, unlike other libraries that are more focused on quality checking rules, now for this library, the strong point, of course, are the patterns themselves. So we have implemented all these patterns that Mav was introducing in this wonderful presentation, and we have done it into two different set of patterns. The first one is what we have called a template. I don't know if Mav mentioned that he doesn't like this name, but this is our, let's say, open way of implementing the ERS approach, where, as you can see here, we have described, this is, by the way, a screenshot of our tool Knowledge Manager, describing one particular pattern of ERS, the state-driven pattern. And in this pattern, you can see, like, you can find the keywords, the main keywords, the while, of course, this is a state, so while, and the comma, and then the ubiquitous requirement at the end. But here in the definition of what is the state for this state-driven requirement, we have identified this as what we call a wildcard slot. This is meaning that you can fill whatever you wish in here, and it will recognize that this is a state-driven requirement. It doesn't matter what you write here. You just start with a while, then write whatever you wish, and then a comma, and then an ubiquitous requirement. And the tool will accept this requirement as a good requirement fitting or conforming with this pattern. However, we have created yet a second set of patterns. In this case, the pattern looks a little bit kind of the same. It is a little bit smaller, but you can find the while here, the comma, a system name, a shall, and the system response in here. But the main difference comes here in this second block. Instead of just having a free typing block, what we have identified here is, for instance, a list of different possibilities to write down a trigger or to write down a state, right? So there are plenty of different options that you can pick one, or you can have the authoring tool guiding you through any of these particular options to write down a state, right? Then what else? Of course, even if I love this ERS approach, but sometimes you will find the need of some tailoring. So if you feel like needing tailoring, then you can, of course, use the Knowledge Manager to tailor the patterns according to your specific needs. This tailoring might include, for instance, just to adapt your requirements for different levels of abstractions by means of changing the types of triggers or conditions or responses, or allowing other modal verbs. Most of the patterns that have been presented today are using the shall as a modal verb. In our implementation, we have used shall, should, will, but of course, in some other cases, you will feel the need of using a different number of modal verbs. So if you need this tailoring, you will need our tool, again, Knowledge Manager, to modify a little bit these patterns, hopefully without breaking the global idea of simplicity that Mav was intending when he created these patterns, right? Then, in terms of the inference layer, what normally in our approach we call quality metrics, what we have done is we have implemented these 8 issues that Mav identified in his paper Big Ears, that you can find it. You can find a copy of this in ResearchGate of this paper. So what we have done is we have implemented quality metrics in RQA conforming to these 8 dimensions. Especially as Matt mentioned, out of these 8 dimensions, he found out that 4 out of these 8 are automatically removed just by following patterns. Of course, if you follow patterns, you are a little bit constrained, for instance, in the number of elements that you add to your elements, so that the word requirements that most of the times we find by means of following patterns, he demonstrated that these word requirements can disappear. So we have focused especially on these 4, where even after the use of EARs, there could be, of course, if you see the length of this bar and compare with this other bar, it is almost nothing, but you can find still some untestability or implementation details or complexity or vagueness in your requirements. So we have focused especially on these 4 dimensions. However, as you can see here, we have addressed the 8 dimensions so that you can remove these issues from your documents, right? So more in this inference layer, we have implemented yet a third set of patterns. In this case, it is not a set of patterns to provide quality checking or to provide aid or help in writing the requirements, but these other patterns are more intended to allow us to extract information from your specification, so that it could be very easy to populate these dictionaries, even if you start with domain ontology that is empty. There is nothing about this. No specific information for your business domain, but with the help of these extraction patterns, we can very easily identify what are the system names or what are the states or what are the main triggers in your specification. So this will be demonstrated in a live demo in a minute, right? All this in our approach is not, let's say, in the backbone of the tool. So EARs is not the backbone of the tool. EARs is a library, of course, a very important library in our approach. But this allows you to combine the EARs library with other libraries. So, for instance, we can have users willing to have the EARs patterns while checking the quality using the INCOSE rules. As defined in the INCOSE guide for writing requirements, right? So following our approach of flexible libraries that you can combine as you wish, you can start with your own domain-specific dictionary and then import the EARs library together with the INCOSE library, so that you can end up with the combination of patterns and rules that you wish, right? All these libraries can be downloaded for free from our website. Just go to reuscompany.com/libraries. Then, before I start with a live demo, I hope that short, because we are running out of time. Just to mention, these are the 5 tools that conform our systems engineering suite. Out of these 3 tools during the demo, you will see, out of these 5 tools, you will see just 3 of them during the demo. I will focus on RQA, the Quality Studio. This is the tool that allows us to connect to the different requirements repositories. Remember that RQA is not a requirements repository itself. It must connect to external repositories. But here is where you can deal with the different quality metrics. Then we have here Knowledge Manager, KM. This is the tool that we use to deal with the dictionaries and the patterns. So all these 5 layers that I was mentioning before are managed in KM. And finally, of course, KM can also connect to external tools. But finally, the authoring tool, the RAT tool, that is an actual plugin on top of many of these well-known. All these tools are covered with RAT plugins, and we have some others. So coping with most of the widely used requirements engineering tools in the market, so that all these authoring help can be found in real time on top of all these tools, right? So using these tools, we could successfully implement the following use cases. The first one is checking conformance of legacy requirements with the EARs pattern. So we can take an existing document and check whether or not this document is conforming to the patterns as defined by EARs. Of course, we can write new requirements following the EARs patterns with the authoring tool. We can check the quality rules for these legacy requirements with RQA, or we can involve all the types of rules for the assessment of the quality of your requirements. Remember what I mentioned about, for instance, the INCOSE rules, or the rules as defined in the NASA Systems Engineering Handbook, for instance. For this use case, we will be using RQA. You can have, of course, real-time corrective checking for the new requirements that you write. We will be using the RAT add-on for this. You can tailor the ES patterns using KEM, as I mentioned. We can automatically parse non-structured documents and extract from them the requirements or the sentences that are conforming the patterns, the structure of the ES patterns, or we can extract the main building blocks like conditions, states, and system names, as I was mentioning. So I have a video with a demo. This is something like 20 plus minutes. Welcome to this tutorial where I will be showing you how our tool RQA, the Quality Studio, has implemented the patterns and the recommendations in the ERS approach. ERS is the easy approach for requirements syntax. So this is RQA, and now I'm opening an Excel sheet that contains a number of different system requirements about RQA itself. If you take a quick look at this requirement, they seem to be compliant with the ERS patterns, if you know this approach a little bit. But let me just analyze the quality of the document. This analysis includes not only some basic rules, some basic quality rules, but also rules that check the conformance of these requirements with the patterns. So now that we have this, as you can see here, not all my requirements are 3 stars. So let me show you why. And in some cases, this is just due to the fact that some important pieces of information could be missing. Like in this case, according to the ERS approach, these triggers should somehow name the main actor. So when requested, is missing which actor can request this operation. So this is why the tool is understanding that this requirement is not good enough. So let me try and move forward and show you some other examples of metrics. If I click here, then what I have is not the list of metrics anymore, but what we have now is the list of metrics that has been analyzed for this particular document and not the requirements anymore. So we can see what is the most dangerous metric, or the metric that is found in more requirements. In this case, it is this one. So it seems that 3 requirements out of my 30 requirements are not following the structure. You can just double click, and the tool identifies for you which are the requirements with 1 star with low quality for this particular metric, not for the overall quality analysis, but just for this metric. So you can see like this requirement here is not, it seems to be kind of a ubiquitous requirement, but it is using must, and must is not recognized as one of the keywords for the ubiquitous requirement. So this is why it is detected as a non-valid requirement. In this case, it is starting with, in the case RQ detects whatever. This is not one of the keywords that is recommended by the tool. And in this other case, we can see that there are some other issues that are preventing this requirement from being compliant with the pattern. So you can find that this requirement is including multiple triggers here, when and an if. According to the cardinality of this ERS approach, only 1 trigger is needed for each requirement. And of course, then it is not, this requirement is not following the structure. So we can close and open the second issue, which is to avoid the use of parentheses. This is a basic metric, the identification of multiple triggers that I was mentioning before. Now it happens in 2 of my requirements. So the one that I was opening before, but also in another one like this one, right? So these 2 requirements are using either 2 when or 1 when plus 1 if. So in both cases, this requirement is not compliant with with the recommendations of years, right? So what else can we find here? So for instance, if I go down a little bit, then I find that there are some the tool can also detect the order of the keywords. One of the good things of years among all the different good things that you can find in this approach is that it recommends you to follow always the same order in the definition of the keyword. So this requirement is including an if statement, it is including a while state, right? But normally the order should be first the state, first the while, and then the trigger in the form of an if in this case. So this requirement is not following the structure, so that it is highlighted by the tool. You can find plenty of other requirements or plenty of other metrics, sorry, like some requirements, only one with some misspelling errors, or some requirements with vague terms and so on and so forth. So these are the typical rules that you can normally find in our tools, especially when we import not the EAS library, like in this case, but when you import for other libraries like the Incose Guide for Writing Requirements library, you have plenty of similar and much more advanced metrics, right? So let's go back to the full view, where if you don't know RQA, from here you can see what is the current state of your requirements. So this is the level of quality of my requirements. You can see what is the quality evolution of my requirement, how this quality is evolving along the time. You can generate very quickly. You can generate quality reports, including the findings of this document. So what are the issues that has been found in the document? So this is my report with the charting, the most dangerous metric, this one, the structure, as I mentioned before, chart including all the different metrics involved in this quality configuration, and how many requirements are not performing well according to this metric, and how many requirements are performing well. And then for all those requirements that are not rated as high quality, then you can find the reasons why it is not high quality for each of these requirements, right? So let me close the report and keep moving forward. RQA can show you the details about the quality of any of them. If I open this one, so now RQA detects that this requirement is not fully following the structure for an unwanted behavior requirement. We can just see from here what is the description of this pattern, what are some examples and the structure. And clearly we can see that this should start with an if keyword, then a trigger, then the keyword then, plus the system name, shall, should, will, and the system response. So clearly this is not following this structure. So let me just remove entirely this requirement and start from the beginning. So I start with the first keyword, if, the system RQA detect and unauthorized access, comma. Now the tool offers the following keyword, then the system, RQA again, QA. Now I'm offered the three possibilities for the modal verb. You can customize and choose if you want to use always shall or should or shall must or shall should will or whatever. So shall. Now the action itself. So warning message. And the message. Check with the license administrator. So now when I finish my requirement, then the good news is that this requirement is green and green everywhere. So this green frame is meaning that this requirement is fitting with my pattern, while this other green is meaning that there is no issue with my rules. So I can save in Excel, and my new requirement appears here now, of course, with 3 stars and high quality. Now we can move forward and check other capabilities of the tool. So I click on the consistency tab, just in order to look for duplicates. So this tool is using a semantic search engine to find duplicates in your specification. And it is finding, for instance, that this and this requirement are somehow duplicated. So this one goes something like, if the license of RQA is expired while RQA is in real-time mode, this one is representing exactly the same requirement. The only difference is the order of the 2 main clauses. So this is why the similarity is giving us 100%. If I go down a little bit, then we can find yet other examples where the tool is not fully representing the same information, like in this example, when a requirement module is opened by an author. Here we can find things, this requirement which is similar 100%, saying something like when the user, which is not the author, is now the user, when the user connects to a requirement module. So the tool understands that an author is a special type of user, and recognizes that to connect to a module and to open a module is representing the same action. So this is why, even if the content of these 2 requirements is slightly different, but the similarity of both is 100%, right? So this is all this is based on semantic search engine, as I mentioned. Let's continue a little bit with some completeness metric. In this library, we have just implemented one consistency metric, the one for to look for duplicates, and one completeness, just to make sure that we are using all the different patterns that we are offered by EARs, right? In this case, the tool understands that there are 10 requirements that are written following the event-driven requirement, 10 ubiquitous, 5 unwanted, 1 optional, and 1 state-driven, right? So this is what is found with the tool. So mainly the key focus in here is just to detect that your specification is not missing unwanted behavior requirements. So normally the typical element that are missing is that we as requirements engineers, we miss this unwanted behavior. So in this case, I'm using 5 of these, so I should be happy with this figure. So I click OK, and I continue, right? So now the second part of this demo is not just to show you how we can analyze the quality of your requirements, but it is on how we can extract information from your documents, right? Here, when you import your library, you will find not only the EARs patterns and the EARs quality rules. All this is found here, but you will also find some extraction metrics. These metrics, when I apply the extraction to my document, so I change from the EARs configuration to the EARs extraction. Okay, so when I change my configuration, then I'm not, when I analyze the quality of the document, I'm not aiming to find defects, but I'm aiming to find elements like I want to check all my system names, or I want to check all my conditions, and so on and so forth, right? So I analyze my 30 requirements. It only takes just a few seconds, right? And I can now see the results in the metric tab, right? So if I click, for instance, on conditions, then I can see all the different requirements that are having conditions, and here I can see all my conditions. In this case, for instance, if I filter and I search for the conditions that I am using, including the word license, then I find that I have this is repeated once, this is once, and this is once. But when you go on this in detail, then this one says if the license of RQA is expired, this one is if the license of RQA expires. So clearly these two conditions are exactly the same. So the recommendation of in the name of consistency, not only consistency of the names of my components, but also consistency in the definition of my triggers and conditions and so on. So we should be editing one of these in order to make these two the same. I'm not fully sure if this one is exactly the same. Probably the three should be represented exactly with the same condition, but at least these two, of course, they should be represented, right? So I close this. So this is the kind of things that we can do with this extraction metric. Now, if I double click on the names, then I can also find that, of course, my requirements are mentioning plenty of different nouns and names, but there are only two nouns in my requirements that are actually representing the system name. So the system name which is in front of the shell, right? In my case, 20 requirements are using RQA, while 3 are using RAT as the subject of the main sentence. If this document is intended to be the system requirement specification for the RQA, probably these 3 requirements are not well stored in this document, right? So we should be moving this to another document. Well, let's move forward a little bit. Now I will show you how we can use the capabilities of the RAT tool in this particular case, just to extract information from an unstructured document like a PDF or Word. Now I'm connecting to doors. Remember that RQA can connect to doors, Word, Excel, and plenty of other tools, requirements management tools in the market. So I now click on the RQA document. This is the first time, so the tool is asking me which quality rules I want to use. So I will use the years configuration of rules and metric and patterns. Sorry. And you can see like the document now is empty. There are no requirements in here. However, I have a document here. So if I open my document, you can see like this is a system requirement document for the RAT for the RQA system. So what is the scope and what are my requirements? So these are my requirements. Now I want the tool to be capable of parsing this document and extracting all of those sentences that are compliant with our pattern as defined in the ES approach, right? So these are all my document, all my requirements in the document. So I move this a little bit here. I click on extract. I pick my document. I close the document just in case. Okay, so close there. Select my document. I apply the patterns that I want to use for the parsing and extraction. Here you can see like I have a set of patterns for the extraction of the building blocks of the patterns, as I was showing you before. Plenty of patterns for metrics here and there, and that too for the ES patterns. This is the set of patterns that I was showing you before during the authoring stage, while these are the patterns that we use for the extraction, especially when we are dealing with business domain whose terminology is not still part of our control vocabulary. So this is plenty of open spaces for you to write whatever between the different keywords. So this will be the templates that I will be using now. So I click OK, I click on extract, And now it is just a matter of a few seconds that I have all my requirements in front of me. Of course, you can now edit the quality of this requirement, and you can perform everything that you can normally perform with the authoring tool or with RQA, right? So what else? Let me keep showing you advanced stuff of our implementation of the EOS patterns. Now I will be closing. I will be minimizing this document, and I'm opening back my Word document just to show you how the RAT plugin can also work in Word. So I scroll down, I go to the final requirement, and here you have a requirement that RQA identified like probably not a very good requirement. So the quality of your requirements, something is wrong here, must be analyzed with the RQA, then parentheses, using the CCC approach, whatever. So probably this is not the best requirement ever in at least according to EOS. So I can just select the text of my requirement, and I can open the RAT add-on. So this is our add-on. Now I have my requirement in the authoring tool, plenty of red stuff here and there. So it seems that this requirement is not an ubiquitous requirement, or is not following the format. I'm using misspelled words. By the way, it is very quick to remove this. So you can use the capability of RAT to fix this. Now it is a requirement. And in the case of CCC, it seems that CCC is not part of our vocabulary. It is an unclassified noun. By the way, if I move the mouse over other terms that are part of my vocabulary, I can see what is the definition, the current version of RQA Quality Studio extends, blah, blah, blah. I can see like this is part of the SES suite. It's a kind of a software tool. Now it's representing the role of a system. So all this is part of my requirement, of my vocabulary. So if I want to write this, it is written in passive voice using must, while our configuration will be requesting you to use shall, will, or should. So let me rephrase a little bit, and something like let me remove this, the RQA shall analyze the quality of now I have plenty of green stuff, so it seems that this requirement is or conforms with the definition of this ubiquitous pattern, and there are no metrics that are involved in this, so it should be okay. However, if you look at your requirement, it goes something like the RQA shall analyze the quality of the requirements. So the quality of the requirement has not, or you don't have to keep analyzing the quality of your requirements eternally, over and over. So it seems that probably this is not a very good example for an ubiquitous requirement. So normally, if I was following the EOS approach, I should prefer something like event driven or state driven. So for instance, now of course when I change it to a state driven, now this requirement is not conforming to the structure of state driven. But if I write in front something like while in real-time mode, comma, the RQA shall analyze the quality of the requirements. RQA is in real-time mode real-time mode, comma, the RQA shall analyze the quality of the requirements or the quality of the current requirement. Then hopefully the tool will identify that this is a valid requirement. So this is green here and green there. So I can just save and close. And of course, remember this new text appears now in replacing the previous text. And remember the comments that were removed using the CCC approach. So that's all. Thank you very much.
Okay, thank you, Jose, for your wonderful presentation. We do appreciate it. And well, we are going to draw some main conclusions from this webinar. First of all, we have created a library, a knowledge library covering layers L3 and L5 of the ontology. We have this library already available in our website. Please, you can follow the link shown in the slide for it. Since you're going to receive the video, you will have this. You don't have to take note of it. And finally, our system engineering suite covers all of the use cases described in this webinar. And also in the next slide, you can see all the following reference from MAP, that they are all available on ResearchGate. And EARS easy approach for requirement syntax, big ears, listen, then use ears, listen, learn, and also 10 years of ears. As I mentioned, they are all on the ResearchGate. And we also would like that this, okay, this is the contact to send direct questions to MAP. It's also in his webpage. So you can direct questions about ears specifically to him. And also, I would also like to mention to you a list of our next webinars from the Reuse company, so we can keep in touch. The first one is going to be hosted by Obeo on November 5th, 2020 at 4 p.m. Central European Time. And this webinar will show our implementation of the RAT for Capella. All the capacities that you have seen today and the ones you previously know from us are at the disposal of Capella users with our new add-on tool for Capella, okay? And the next webinar will be a webinar in basic aspects of our tools, but in German language. For those of you who have German as a first language, or you want to receive it in German, the date for this webinar will be November 26, 2020 at 9 a.m. Central European Time. And then we will do the same day, but a different time at 4 p.m. We will do the same webinar, but in Spanish for Spanish-speaking people here in Spain or in Latin America, or as a second language if you want to attend to this webinar. Okay, so now let's go to the Q&A. We have a couple of questions here. I think the first one was received when MAP was talking, so I guess it was for MAP. Would it be okay to put "and" after the precondition?
You won't necessarily have it immediately to hand, but you may remember I said precondition brackets S, so there can be more than one precondition. So, for example, in an aero engine control system, you might have things you want the system to do whilst the aircraft is in flight and the engine is running. So you want both those things to be true. So having an "and" in the precondition, having more than one precondition is definitely acceptable, yes. If that's what I think the question is asking. If whoever asked the question wants to ask a subtly different question, I'm happy to answer that as well.
Yeah, they can go ahead and write it in the chat box.
Yeah.
Anyway, we have a second question. It says, what about tables? For example, allow combination of parameter values and enumerations could be quite useful in some cases. For example, to prevent having many requirements with repeating parts.
Okay. So my general answer to that is I've always said that most people write most of their requirements in natural language, and EARS helps most people write natural language requirements more precisely and more correctly and more consistently. That is my general comment. I would also say, though, that in many requirements documents, if you are mainly writing in text, there may be some requirements that you don't write in text because it's more appropriate to write them in another notation. Some requirements are effectively a mathematical formula. So it makes much more sense to use a mathematical formula than try to write them in English language. Some are inherently visual, so you might have a picture. And in some cases, some sort of table may be more appropriate, yes. So I think the sort of example that is being mentioned in the question, if something is inherently a table, if that's the most logical way of presenting it, then I would say you perhaps don't necessarily need to use ears to specify that sort of requirement. You can use a table. And perhaps relating this to the previous question as well, as a rule of thumb, if you have 2 or 3 preconditions, you can write an ears requirement for it, and it's easy enough to read. But as soon as you get to 4, perhaps 3, 4, any more than that preconditions, if you're saying while this and this and this and this, it gets much harder to read. So at some point, it makes more sense to have something like a truth table. So that's just a judgment of what makes sense.
Okay. Okay, thank you, Matt. And well, we have here Mark Roney saying that it's a very interesting webinar. Thank you very much, Mark. We're glad you like it. Also from Subramanian Palanyapan says useful one. Thank you. And we have a question from Andrea Salawi. Is it a problem to change the sequence to system name first, followed by system responses, and then trigger preconditions, etc.?
Well, is it a problem? That would not be EARS compliant. So in that sense, I would say, yes, it's a problem because that would then not be an EARS requirement. Is it a problem? I think the main thing EARS gives you, one of the main things it gives you is consistency. So even if you have different people writing requirements, if they all apply the EARS approach, then all their requirements look much more similar to each other in structure than if they were just all writing pure natural language. I suppose if all your authors were writing in the same structure, then you'd get consistency. The problem is if you start allowing people to put preconditions at the end or whatever, then they become inconsistent between authors, and it's harder for people reading them to understand them. I mean, I know some software requirements are written the other way around, if you like, with the conditions at the end. So I would say be consistent within a document and at a level. But people have found that EARS is more intuitive because it's the temporal order. So as far as EARS is concerned, I would say you should not put the conditions at the end.
Okay. Thank you very much. Oh, we have another last minute question. Says, I've got a question related to architecture sequence or state chart.
Yes. Hello, Alex Fournier. Thanks a lot for your presentation. It was really nice. Well done. You said inside the presentation that if we have inside the architecture, we have a sequence diagram or a state chart, you are able to generate automatically some textual requirements based on it?
If that's a question for me, I don't think I said automatically. Okay. So, I mean, nothing I said was anything to do with the tool, just to be clear. So I developed, or I was one of the people who developed EARS. So everything I talk about is about EARS as a notation and a process, if you like. Anything specifically about the tool was what Jose was talking about, and that's based on EARS, but we haven't actually worked together on that, just to be clear. So no, I'm not talking about automatically. When I said, in the general case, when I said that EARS works well with models, I suppose what I mean is when at any stage in a system development, I think it's useful to cross-check between different artifacts that you've generated that have maybe come from different sources or whatever to ensure consistency and completeness. So, for example, if you're writing requirements for a system like an everyday system that people use in training, typically like a cash point machine or a pedestrian crossing, if you've got a set of draft requirements, it might be worth trying to do some scenarios to see, have we covered everything? and then you do a scenario and you slot in your existing requirements, and it makes you realize you're missing something, or you've got some duplication or something. Or you could go the other way around and say, oh, we think we're going to do this system that's inherently about a linear sequence, so we'll do some sort of scenario, and you write the scenario, and then you start inventing or making up or proposing requirements for each part of the scenario, and then you get some requirements which you could write in ears. So you can start with a scenario and write requirements, or you can start with a partial set of requirements and look at a scenario, and similarly with state charts. So I suppose what I was saying was that the elements of a state chart and state transitions on a state chart, and the elements, the entities and actions on an activity diagram, and the how you go from one event to another on a state chart, on an activity diagram, sequence chart, and so on. All those things would be useful for generating EARS requirements, and vice versa, but not automatically. That's not what I was talking about. Some people have done tools that can do some of that, and maybe Jose has an answer for what the tool will do, but I'm not knowledgeable enough about their tool to answer that part.
Jose,
yes, Alex. Yeah. Of course, we have experience in both ways, in generating requirements out of models and generating models out of requirements. We can, well, it is 7 minutes past the hour, so I think that, and we still have some other questions. So if you prefer, Alex, just contact me and we can discuss this topic offline.
Okay.
We have, okay, thank you, Alex.
Okay,
Frank, you have some other questions?
Yes.
Yes, Alex, you can contact at contact.reusecompany.com or sales@reusecompany.com. Okay, let's go to another question from, I'm sorry if I say your name wrongly, but it's a little bit difficult. From Yuha Ohala. How unwanted behavior is written in EARS if there is some preconditions involved? Or if, or can I combine while precondition if?
Short answer is yes, you absolutely can say while precondition if. This is only, the fact that I didn't make that clear is just because of time, and I can't cover every possible variant in the time we have. But yes, the key thing is that if comes before the unwanted trigger. So you can have preconditions and then if, indeed. Again, as Jose said about questions to him, if people have supplementary questions or want clarifications to some of the answers, please get in touch. I'm happy to discuss things further. But yes, absolutely, you can have preconditions and then if.
Great. Okay, as you can see, Jose is put his slide with his email, and also Mab. We saw the email directly. So if you have questions about EARS, go to Mab, and if you have questions about the tool, go to Jose or to any of the main email addresses of our reuse company. We have another question from Eero Usutil. Some of my clients who are currently using EARS are interested in implementing automatic quality checks. Can you characterize the prerequisites of taking RAT into usage with doors? Whether it is mostly plug and play or whether it is necessary to construct several glossaries models. This is directly to Jose.
Yeah, of course. So when it comes to using the tool to actually analyze what the users are writing, as I was mentioning, we have implemented two different implementations of these EARS patterns. The first one is more open and free. Of course, we can put our tools on top of doors as an add-on, both doors classic and doors next generation. So we have add-ons for both of them, allowing you, if you still don't have the vocabulary, we can use the free typing combination of patterns, as I was mentioning. While if you do have some content for this vocabulary, then we can use the second. So this is the more constrained block, and this is just the more open combination. In any case, as I was mentioning, we can do we can combine both approaches in analyzing requirements with the open. With the open patterns, meaning that there is no need to have a domain-specific vocabulary, so that our own tools can help you gather and retrieve these model names or state names or system names. And so all this can be captured automatically by the tools in order to populate the glossaries. And once the glossary is populated, then you can do whatever you wish. Another possibility is, I didn't explain it in detail, but you can also connect our tool Knowledge Manager to modeling tools, so that if these glossary are already, for instance, the state names are already in a state machine in Rhapsody or Cameo or Capella, whatever, then we can connect the KM in real time to these tools, so that all these glossaries can be automatically retrieved. And when you are writing a requirement on those with the help of the RAT add-on, then you can check in real time the quality rules as described in RQA, use the patterns of years that we implemented in KM, and use the terminology or the glossaries that are coming from your preferred modeling tool. I don't know if this was your question.
Oh, I guess yes, because he's thanking you for the answer.
Yeah,
right
now
now, yeah, I think there's no. Well, okay, yeah, it was very thorough. So I guess
you can contact us if you need some clarification, or if you want us to demo this particular topic.
Exactly. You can contact, and we can prepare a demo, short demo, whatever for you. Okay. Any more questions? None. Okay. So thank you very much for attending the webinar. You have all the emails, the contact at reusecompany.com, sales at reusecompany.com, Jose Fuentes at reusecompany.com, and then you have also the map email, and it's map at alistairmaybe.com, and the webpage. So thank you very much, and good morning, good evening, good night, wherever you are. Thank you very much. Goodbye.
Thank you. Goodbye.